probability question here, and the idea of mutually exclusive comes into it, and the idea of independent, and it uses two very common rules for probability, the addition rule and the multiplication rule. The first part of this, A and B, probability of A and B, and the multiplication rule for independent events is that the probability of A and B for independent events is probability of A multiplied probability of B, which tells us 0.3 times 0.8, 0.24. Easy enough, as long as we remember the rule, of course. B. The addition rule now. What we've got is that probability of A or B. The addition rule tells us that this will be the probability of A plus the probability of B. And thinking diagrammatically, if we think of a Venn diagram, the probability of A or B, all of this, but in adding the probabilities, what we do is we add this intersection twice. So the addition rule tells us to take it off. That's the addition rule. And of course, we've already figured out the overlap, 0.24 there. So we should be able to suggest that what we've got is and that's going to give us 1.1 minus 0.24, which I believe is 0.86. Are A and B mutually exclusive? No. Mutually exclusive would suggest that what we have is this. And the one thing about mutually exclusive events, which are completely separate, is that you get no overlap. And these are not mutually exclusive because clearly A and B, the overlap, equals 0.24. For mutually exclusive would suggest that overlap would equal 0, not mutually exclusive. Question done.